This is Annie Powell, and today I will be discussing Physics 2212, Lab 2, Charge Tapes Revisited. So for the introduction, the goal of this lab is to expand upon Lab 1, focusing on finding the electric force on one tape from another, as well as gravitational systems and surroundings. We have our system, which is tapes, and surroundings, which is the air. Some important concepts. So here we have Coulomb's law, Newton's second law, which is that force equals mass times acceleration, and the idea of superposition, which describes that the net force on an object is the vector sum of all the forces acting on the object. And then the results of the lab, just kind of a brief start to that, is that the gravitational force and the electric force are going to be equal due to superposition, and the fact that the net force is 0. And so then we have what gravity equals, which also equals the electric force. And then the fact that superposition provides answers using different sections of the tape rather than point charges, so it's more precise. Assumptions and the model. Each charge is equal across the tape. Air resistance is negligible. The two U tapes have the same charge, and any constants are obviously assumptions as well. And in this lab, for the model part, rather than point charges, we have each tape in sections to calculate. This is the model instead of the point charge model. So then we have our glow script. So just a review of what I did to kind of change things. I put in the mass of one piece of tape and the charge that I received in lab 1. And then I typed in some equations to find the electric field. So we can see that here. And then on the next page, I put in the separation between the two tapes as the distance of the top tape, and left everything else pretty much the same. And then I kind of had to mess with this E scale a little bit and ended up leaving it at 1. And then this next part on the bottom was to find the force of the top of the tape on the bottom of the tape. And so we can see me finding distance vectors, and then the electric field, and then the force from there. And then we also would say that the electric force is equal to the gravitational force. And then here at the bottom, this is just the example of printing the results. And so in the next part, we have the results printed here, electric force and gravitational force. The scale is a little bit off, but the digits are the same. And then here is the model itself with the arrows. Some sources of error in this experiment: incorrect coding or calculations due to human error. We assumed that the charges are equally distributed and that air resistance is negligible. These may not be valid assumptions, of course. The measurements I had of separation distance, mass, and more may not be correct, and both tapes may not have equal charge, which is what I assumed. So a lot of the assumptions would be the sources of error. For the discussion questions, what if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use experimental data to produce a point charge model to the value you got with your line charge model. So the point charge model is an overestimate significantly. It's a lot less precise because it doesn't include repetition with small error. So by doing small groupings with less error each, we have a total error which is less. So why do these estimates differ? Which value is more likely to be closer to the real value, and why? The estimates differ because the point charge model gives a broad estimate versus a sum of very small estimates. The line charge model is more accurate because it considers the electric force in steps to add sections with a smaller error each, and therefore a smaller overall error, which is what I said before. Okay, and then the conclusion reiterated. So we have that our force of gravity equals our electric force, and both of those are 2.75 times 10 to the negative third newtons, roughly. This is due to the principle of superposition that says that if we have an F net of 0, then it must be Fg plus Fe. So one of them is the negative of the other. This is more accurate than the point charge model calculation based on the previous discussion question that I had before. Thank you for listening. This is Annie Powell, and today I will be discussing Physics 2212, Lab 2, Charge Tapes Revisited. So for the introduction,